what does it really mean for an AI to think? Today, we're diving deep into performance is now a feature. Interview.net performance optimization user tolerance for latency has collapsed below 200 millimeters. Throughput demands double every 18 months performance is no longer a back-end concern. It decides revenue. This talk introduces a systematic performance engineering model for .NET, but here's where it gets interesting. The diagnosis gap. Traditional profiling answers what is slow. It fails to answer why under load and what will break next. Memory pressure, Threadpool starvation, and GC spikes remain invisible. Most teams optimize symptoms, not root cause. A disciplined interviewing process for your runtime is missing. So what's the real problem? Let's talk about the root cause stack. 3 hidden layers dominate .NET performance degradation: Threadpool oversubscription, under burst traffic, Gen 2 garbage collection, pauses blocking request threads, async await completion. Flooding overwhelming I/O pipelines, each layer feeds the next, creating cascading failures, observing them in isolation masks, systemic collapse. This raises a critical question from observation to interrogation. Breakthrough, a structured interview protocol for the runtime itself. Instead of sampling, we inject controlled demand patterns. The runtime reveals its stress boundaries predictably. We call this deterministic stress induction. This shifts performance from forensic to predictive. Now, let's zoom in on the interview.net system. A 3-plane architecture: injection plane synthetic workload generation, observation plane CLR, event tracing with contextual correlation, decision plane heuristics engine mapping symptoms to root, causes all planes operate synchronously during controlled experiments. The output is not a flame graph, it's a performance diagnosis report. Here's something most people overlook: injection plane generates transaction patterns that mimic real-world surge shapes, controls concurrency gradients, not just request, counts surfaces, thread pool, injection points, and async completion queue, depths built on a custom task CJITer to bypass default thread pool heuristics. Think about this for a second. Observation plane hooks into CLR runtime events via EventPipe, correlates GC triggers, thread pool starvation events, and lock contention, builds a timed causal graph, not isolated metrics. The key: measuring delay between cause and visible symptom. And this is where things get complex. Decision plane. Heuristics engine trained on known .NET failure signatures matches observed patterns against a taxonomy of 40-plus performance defects outputs, ranked root causes with confidence scores, eliminates the my best guess debugging loop. Actionable. Prescribes code, config, or architecture changes. But here's where it gets interesting. Interview workflow. Define workload profile 2. Run stress induction 3. Collect synchronized telemetry 4. Receive diagnosis typical cycle 8 minutes from question to root cause. Compares to days of manual. Profiling integrates with CI pipelines for regression detection on every commit. So what's the real problem? Let's talk about measured impact. Teams using Interview.net report 73% reduction in P99 latency after targeted fixes, 40% lower cloud compute, cost through right-sizing MTTR for performance incidents down from 6 hours to 22 minutes, diagnosis precision, eliminates speculative performance tuning commits. This raises a critical question: the observable runtime paradigm. This approach moves .NET operations towards self-diagnosing runtimes. Deterministic stress induction becomes a standard CI gate. Performance regressions are caught before deployment, deterministic, not probabilistic. The interview protocol applies to any .NET workload, microservices, functions, monoliths. Now, let's zoom in on the next diagnostic layer: Future autonomous remediation agents that apply prescribed fixes, closed loop, inject, diagnose, apply, verify, runtime, self-interview becomes continuous, not point-in-time. .NET performance engineering shifts from art to engineering discipline. Interview. .NET available now for early access.